Welcome to another episode of This Is My Architecture. Today we have Udit, CTO of OLX India. Welcome, Udit.
Thank you.
Udit, please tell us about OLX.
Sure. So OLX is into online classifieds business. It's into 40 countries and possibly the biggest online platform where buyer meets sellers.
Operating in 40 countries, that must be a lot of technologies going in.
Right.
Could you please take us through some of the key architecture principles?
Yeah, to just simplify it, we are looking at reliability and agility. And for that, we are building a lot of microservices powered by AWS.
Great. So it's a microservice architecture. There must be multiple services. Could you take us through one of the key services?
Sure. So today we can talk about chat. So in any online classified business, there are buyers, there are sellers, right? And they need to communicate between each other.
Yeah.
So what we have is a chat. It's a real-time messaging platform within the OLX app.
Oh, how does the architecture work? Could you please take me through this?
Yeah, before we just go about the architecture, I need to also tell you about the real problem statement, right? So we have 50 million app downloads just in India.
Okay.
What that translates into is 100,000 user connections always open at any given point in time, which further translates into at least 20 million messages per day.
20 million messages per day. That's a huge scale. How you're building this architecture, how it works under the hood?
Sure. So at a meta level, we have 3 layers. First is the authentication layer. The next is the messaging layer. And the third is the analytics layer.
Okay. And how does the authentication work out for you?
Sure. So the user is using an Android app. The app connects to the API gateway. Behind API gateway, we have the Lambda function running.
Okay. And what's the role of Lambda function?
Sure. So this Lambda is nothing but a custom authorizer. It returns a JWT token to the app, which is then used further in the payload for all the requests.
Okay. So Lambda works as a custom authorizer for you. And I believe after that, it goes to the chat engine.
Right.
How does that works out?
Sure. So on the chat side, we have the ELBs running. Behind the ELBs, we have multiple EC2 layer, or basically multiple EC2 machines running. On the EC2 machines, we have EJBD application server.
EJBD, that's an interesting choice. Can you tell us why you chose EJBD?
Right. So EJBD is an XMPP-based application server built mainly for real-time messaging.
How do you scale that? You have 20 million messages per day.
Right. So at any given point in time, we have the auto scale running. So if there is any marketing campaign and the traffic goes up, the auto scaling kicks in.
All right. So you scale the entire chat platform.
Right.
And where do you persist your chat? How do you bring persistence to this architecture?
Right. So EJBD generally runs with any flavor of MySQL. What we have done is we are using Aurora instead of the vanilla MySQL.
Okay. Aurora, why you chose Aurora, not, let's say, RDS? We also have RDS and not on EC2. Why Aurora?
Right. So as I said, right, we have like 20 million messages going in here. So 20 million messages per day would translate into like TBs of data in like few days.
Okay.
So any database, right, comes in with the problems of backups, provisioning, maintainability. Aurora gives that out of the box.
Yeah, so you have offloaded the heavy lifting part.
Right.
And you also have a Redis. Is it on EC2 or it's a Elastic Cache?
It's a Elastic Cache that we are using. And over here, we are using basically saving the connection data.
Okay.
Like the PID, the presence, and the activity of the user.
The session data gets stored here. And I also see Kafka there. So you're streaming the chat messages.
Right. So once the message goes into Aurora, it actually also gets streamed into Kafka. From Kafka, we basically deserialize the XMPP packet and store that into Cassandra for various analytical purposes. One of the examples could be that we provide smart suggestions.
Okay. That's great, Udit. How do you further scale this architecture? How we are optimizing it further?
Right. So let's go back to our design principles, right? Operational ease and maintainability. Now over here, we have Kafka and Cassandra. Right? Kafka and Cassandra both are like great technologies, but they come up with their own set of operational challenges. With Kafka, we need to maintain Zookeeper as well. So what we are looking at is, can we replace Kafka with Kinesis? So we would be doing POCs for that. Similarly, for Cassandra, we would be doing POCs if we can replace Cassandra with DynamoDB.
So you elevate the problems with manageability and operational aspects. Oh, great. Thanks, Udit. Thanks for taking us through this architecture.
Thank you.
Thank you for watching another episode of This Is My Architecture. Thank you.